So I'll say that again to make sure. So osmosis, if diffusion in general, if somebody says simple diffusion is the diffusion or the movement of solutes, then osmosis is the diffusion or movement of water. All right, so when water moves across the membrane. And again, it's going to be a selectively permeable membrane. Some membranes are really good at letting water through, some aren't so good at letting water through. Not all membranes let water through easily. Almost every membrane will allow water through, a biological membrane. So osmosis does occur, all right? But when we're talking about water, they have these helper proteins called porins, and porins help water move through the membrane. So some of your cells have a lot of porins, and others, or some will have more porins than others, but porins are membrane proteins that allow water through. Water can move through the membrane without it, but it's very difficult because it's what? What is it about, even though it's small, what is it about water? It's polar. So it has a hard time getting across the membrane easily. Yes, it's very much because of light dissolves light. It's just a protein. It's a protein that allows water to go through. Membrane protein allows water to go through. So types of facilitated, we have passive transport, right? Where you go from high to low. Osmosis is facilitated. Why is it facilitated? Because of porins. Porins are the facilitator. What does facilitated mean? Help. So water is helped across the membrane. And we do move from high to low. So water will move from high to low, just like the solutes do. It allows the cell to maintain a water balance in the environment. So and we'll talk about what that means. And when we're talking about balance, what do you think we're talking about? Concentration. And yes, the word dynamic equilibrium. So the cell wants to keep that consistent concentration of water. So you can do concentration of anything, right? Concentration of people, concentration of shoes in a room, concentration of solutes. You can also do the concentration of water. Right. So it's how much you have in a specific amount of space, right? All right. So pass-through water channels. Right? So what are the water channels? What are they? What are they called? One of the examples. Porins, right? Porins. So there's more than one porin in a membrane. Absolutely, there's many porins. Good question. Let's just stick with porins. Porins are the water channels. There's a lot of specifics we're leaving out, obviously. Right? I mean, there's a lot. There's a lot we know about what goes on, and there's a lot we don't know. But porins is the protein that you need to know for your exam. Good question.
All of them pass through the membrane.
Say that again.
All of the porins pass through the membrane.
The porins allow water through. All right. Protein channel specific to water. Right? So when we're looking at membrane proteins, we're looking at water diffuses across the cell membrane by osmosis, as you see here. These are free water molecules. Here's high, here's low. So what's going to happen is the water's going to move from high to low. Notice that in every problem they tell you, right? In every problem, in some way, it's not always going to be easy like this where they tell you high and low, right? It's not always going to be that easy, but they're always going to tell you what's high and what's low. Right? They go through the membrane using what? Porins. Some will go through the membrane. They're small enough that they're kind of in between, but it's difficult. There are three possibilities for the direction of water movement. Right? Dear, I know you're shadowing, and welcome to the class, I want to say that. But would you mind taking off your hoodie? If that's okay with you? I appreciate it. Listen, I don't care what time it is, I don't care who you are. I have a hoodie, it's sitting right there. Do I have it on? No, I don't. If she wasn't okay with it, I don't know, I'd have to talk about it. Can I get back to class? Can we take it? Thank you. So there are three possibilities for direction of movement of water. Water moves out, water moves in, and when does water move out? You know what? I don't like it when people talk about words that they haven't defined first. So let's talk about tonic first. What does tonic mean? Tonic in this case, let's talk about that as the solution. All right, let's just call it the solution. So the solutes in the solution. All right, so let's talk about that. The concentration of solutes in the solution. So I'm going to put a square bracket. So tonic is a concentration of solutes in the solution. You can have three different kinds of tonic. Three different kinds of concentrations of solutes in a solution. All those vocabulary words always come back to bite you, right? If you didn't learn what if you didn't learn what we didn't learn. Let me pause this for a second. All right, so listen. Come on. This is stuff that has nothing to do with you. So can we move on? Thank you. That's okay. She doesn't. Hey, I don't want to talk about this. Thank you. So tonic, solutes in the solution is what we're going to call tonic. And so there's three kinds of tonic. Okay. There's hypertonic. Yeah.
Okay, so you said tonic is a concentration of solutes.
I want you to think of the word tonic as a concentration of solutes in the solution. I've said it like 4 times. Right? That's all. Can you do that? Is that something that you can do? Yes or no?
Yes.
Feedback. Thank you. Hyper means high concentration of what? Solute. And we're talking about outside the cell. High means, this is shorthand. Shorthand allows us to take notes quickly without having to try to write out every single word. And then when I go back to revise my notes, if I don't remember, I can look it up and write down high instead of up arrow, if I want to. This is the process of note taking I've been trying to tell you throughout the year. Hypo is low concentration of solute.
Hypo or O?
Hypo, outside the cell.
Why would have an arrow going up?
We just answered that.
Oh.
And iso is an equal concentration of solute. Now, as I said before, outside the cell. Like isolated? No, iso in this case means the same, equal. Okay? Like isosceles triangle means what? Equal sides. Okay, well iso means the same. Isosceles triangle, isosceles, I can't pronounce it. Isosceles triangle. This side, triangle with 2 sides are the same, right?
Yes.
All right, so when we talk, okay, so now let's talk about what these actually mean, if we could. It would be nice if we could. So when we're talking about hyper, it says higher concentration solute where? As opposed to what? Inside. That's important. A lot of kids don't understand how important that is. They get confused. And trust me, when you're doing problems, you're going to get confused if you don't have these definitions straight. Okay? It's going to be a beaker, yeah.
Hold on.
Just listen. Just listen. Really, it's a horrible beaker. It's a malformed beaker. And inside this solution, this is the solution, right? We have some kind of, and it's going to be water, right? Because that's what you're going to find cells, right, in water. We all agree? We could do all kinds of solutions, but we're really talking about water here. But okay, there's a solution. There's water is a solvent, right? And we're talking about osmosis, so we're going to be talking about water. Everybody okay with that? And we know that outside the cell there's water, and inside the cell there's what? Water, right? That's why there's a bilayer, right, where the hydrophilic heads are pointing outside and inside. We know that. Everybody okay with that so far? Okay. Then outside the cell, what if I have this going on? Where outside I have a crazy amount of solutes, and on the inside I have just a few. Right? What is this solution? What is this solution? Is it hyper, hypo, or iso? What is it? Hyper. She got it right. Hyper. Why is it hyper? Because it's higher outside the cell. It's higher outside the cell. So if it's higher out, because why? How does she know it's higher? Look at it. If I look at the concentration, of course I have to assume that there's more dots outside than there is inside. Well, let's just do a hypo. Let's do a hypo. Let's do the opposite. Let's do the opposite, right? Let's do the opposite. So that's this. Let's make sure we understand that this is hypertonic. Hypertonic. What's tonic? The concentration of solute in the solution outside the cell, right? All right. So let's go ahead and do then another cell, and this time well, which one's more concentrated? Inside. So what's this? Hypo. Tonic. And of course there's a third option, and it's really, these are easy, right? You agree? Yeah, they're going to be the same. So 1, 2, 3, 4, and 5, and 1, 2, the volume's less, but assuming volumes are the same, let's assume volumes are the same, right? The concentration is going to be the same. So what is this? Isotonic. So if this is isotonic, hypotonic, and hypertonic, those are the three. That's what they mean. You need to memorize this without question. There should be no question as to the necessity, how important it is for you to know hyper, hypo, and iso. And that's just the beginning, because you're going to have to answer questions using that knowledge. So I would like to see index cards made. I would like to see things repeated several times. So another way we could do this, by the way, instead of drawing dots, is we can do this. Draw 3 beakers. And draw some cells in the solution, and inside I could put, for hyper outside I can put 50%, and inside 20%. 20% what? Solute, right? And what percent water? What percent water if I have 20% solute? What's 20%? 80% water. Does that make sense?
That's in the. That's
Yeah, there's only 2 things, water and the solute, right? So if it's water and the solute, that's what you're talking about. If it's 20% solute, what's the other percent? 80% water. Does that make sense? It has to equal 100, doesn't it?
Yeah.
We're all okay with that? So if it's 50% solute outside, what's the percent water? 50% water. So it's 50-50 outside, and it's 20-80 inside. Which is the outside is what?
Outside is
It's hyper. So this is hyper, right? So that's why they're both hyper. One is a drawing of dots, and the other is a percentage. Now, what if I did the opposite, right? Where I said 80% solute, and then what percent water? 20% water, right? And then outside it's let's say 50-50 still. What do you think? What's going on? This is hypo, right?
Yes.
Now the concentration outside is less than the concentration inside, so we call it hypo. Are we all understanding this?
Okay, so so the hypotonic, that's in the inside. And the hypertonic, that's all like what's in the inside and not what's on the outside.
Right, so I'll say, let's go back to our original statement. Let's look at it again. Tonic means the solute, the concentration in the solution, the solute concentration in the solution. Do we hear that?
Yeah.
Okay. So hyper means it's the concentration of solute where? Outside the cell. Hypo means a low concentration of solute outside the cell. And iso means the same concentration outside as inside. Now when we come here and look at this example, let me go ahead and minimize this and maximize this. When we look at these examples here, in one we're drawing it, and you see there's more dots outside than there is inside. And that kind of confuses people, so often what people will write is there's 20% solute inside. Now, when we're talking about percentage, guys, you should be thinking about what? You should be thinking of a pie, right? A pie chart, like a pie chart. And if we do 20%, and this is just a sketch, so I'll just say that. Let's say this is 20%. Then if this is solute, let me unplug this thing because it's going to annoy me.
You put it.
If this is solute, and this is water, because why water? Because that's what we're talking about in biological systems, the solvent's water. So if this is 20%, how much water do you have? 80% water.
And that's
Well, it depends where. It depends where. If it's inside or outside. When we're talking about hypertonic, hypotonic, or isotonic, what we're talking about is what is the outside of the cell as compared to inside.
So if it was 80% outside.
In this case, like we have this case, 80% water inside, then outside is only 50% water. Did I get that wrong?
I don't understand.
Do it supposed to,
That's what I know.
do it supposed to add up those numbers on corner?
Right, no, yes they do. So just hold on a second. Everybody just relax. 20% solute. Remember, we're talking about hypertonic. What are we talking about? The solute, concentration of solute. So what's the concentration of solute?
20%
Where?
in the inside.
And what's the concentration of solute outside?
50
So which side's higher, outside or inside?
outside.
So that makes it what?
Hypertonic.
Confused me when you did all the adding the 80%.
Right. Yeah, you lost.
All right. You didn't. Did I lose you? Okay.
Like, why couldn't
Did I find you again?
Yeah, you got me.
Okay, I just need you to, I need to know that you got this. You'll see why I mentioned the water, the 80% water in a minute.
Why couldn't you do 20% inside and 80% outside to add up to 100? Can you do that? Like,
No.
No, they're not gonna, the 100% is inside the cell. There's 100% outside, there's 100% inside. You're comparing inside to outside.
So both of them equal.
These two have to equal 100 and these two have to equal 100.
Yeah, you mentioned.
But these two can't equal 100 because you're not talking, this is not the system. There's a system inside, there's a system outside. You're comparing the system outside to the system inside. See how confusing this can be? This is why we're taking one step at a time, and you need to make sure you understand it. And you're gonna make mistakes in the practice problems I'm gonna give you tomorrow. You're gonna make mistakes, that's okay. But you have to learn from the mistakes. Are we clear? Because on the test it's gonna mess you up. So 20% inside, 80% outside. So inside has to be 100%, outside has to be 100%. So when you compare outside to inside, the one that has a higher concentration of solute is hypertonic. The one that has a higher lower concentration outside is hypotonic. And where the one where they're equal, so that let's just do an easy one and say that this is 50-50, and then outside is what? 50-50.
That's isotonic.
That would be isotonic because they're equal concentration.
That makes so much sense.
All right, so we're talking 100%, but the 100% are 100% inside, 100% outside, not 100% across the board.
Right.
We all got it?
Yeah.
Because now it's going to get a little bit more confusing. Sorry. There's nothing I can do. This is the way it is. You have to figure it out. It's just you have to suffer. I apologize. So let's go ahead. We got that. So now let's take a look at what osmosis is. So osmosis is the movement of water. Why would water ever move? If the ions can move, what do we say? If the solute can move, what moves? The solute, right? If the solute, we said that about diffusion, right? If you have a higher outside, if it's 80% outside, I'm going to say 80% solute, and it's 20% solute inside, right? So this is inside, and this is outside. Are we good?
Yes.
All right. So if outside we have 80% and inside we have 20%, then which way would the solute move? From high to low, which would be what?
Outside to inside.
So this is if solute can move. What would happen is and by the way, is this a hyper or hypo or iso? It's hyper, right? Hyper. Because outside is 80. So it's hyper. Isn't a hyper? Outside's higher. Outside is higher. So it's hypertonic. So in a hypertonic solution, if the solutes can move, the solutes will do what?
Is this like those 3 questions?
Yes.
Oh.
If the solutes can move, the solutes will move where? In and out. In and out, yes. Yes, in and out, but mostly from high to low. So in this case,
Outside.
into the cell or out of the cell? Into the cell. The solutes would move into the cell. So everybody sees that, right? So you'd see that solutes are out here, and inside you have a few of them, and so you'd have solutes move in, right? That's what would happen if the solutes can move. If the solutes can move. And we'll see. In a minute, you'll see what happens when they don't move, okay? If the solutes can move, then what's going to happen? The solutes will move in. Do you agree? Okay. Now, there are situations, as we discussed, where the solutes are not able to move through the membrane. For instance, salt or high sugar. It's very hard for solutes to move. When we do our lab this week, we're going to put those eggs in a high salt concentration and a high molasses concentration. And molasses is a sugar. It's a pollen. It's hard for it to pass through the membrane.
So is the egg gonna be cracked?
Sand. No, we're talking about things that would move through the membrane.
Is it hard to move something through sand?
Well, you're not trying to move it through the material. You're trying to move the material into and out of the cell.
So the membrane is
So-
gonna be the shell?
The shell's going to be gone. We're going to get rid of the
Oh,
shell.
that's what I was asking.
Yeah, we're going to get rid of the shell. We're going to dissolve the shell off. The
So
egg.
we're gonna have boiled eggs?
Not boiled. There's going to be a
Raw?
raw. Yeah, don't. You'll have to see it. You have to see it. Just trust me on it. I know. You get rid of the hard shell. What you'll find underneath is the membrane. That's it. And so we're not boiling it, we're not gonna cook it, we're not gonna change it, we're gonna leave the egg alone. We're gonna get rid of the shell. And what you'll get is it's soft, membranous, almost like it'll feel, if you're not careful, it'll break, obviously, right? And so you're gonna put it in a solution, different solutions. You're gonna put one in a hypertonic solution, you're gonna put another one in a hypotonic solution, you'll put a third in a isotonic solution. Very good. So obviously, if the stuff's moving in, if the materials move in, you're probably not going to tell a difference in mass because the solutes are going to be relatively small amounts. However, if the solutes can't, and I can tell you right now that in the lab, what I'm going to do is I'm going to give you solutes that won't pass through the membrane easily. So they won't pass through. So what happens if you have the same situation, 80% solute outside, 20% solute inside? Right, same solution. Right. What are you going to do? And again, this is outside, and this is inside. All right, you have outside and inside. And what are you going to do if the solutes can't move? Where do the solutes want to move?
To the inside.
Inside, but it can't. So it can't move. If solutes cannot move,
And it can't move because it's hard to get through, right?
that's right. It doesn't have the right protein, it's charged, it's big. In case of molasses, the solutes are going to be big. In the case of salt, the solutes are going to be charged. Either way, they can't move, right? So give me a second, write down your question or remember it if you can. If solutes cannot move into the cell across the membrane, then what's going to happen? They're going to stay where they are, but nature needs homeostasis. It will balance out. So what's going to happen is what's going to move since the solute can't? The solvent. What's the solvent? Water. So if it's 80% outside solute, what is it outside water? 20%. It's 20% outside water. Why is it 20% H2O outside? Because outside has to equal 100%. 80 and 20 equal 100. So inside, it's 20% solute, so it's what?
80% water.
80% water inside. So now, water, if the solute won't move, the solvent must. It's going to move through diffusion, and what is diffusion? Movement from high to low of that material. And so, where's the water high? Outside the water's high, you sure?
Oh, the inside.
The water's high inside, so this is high water inside. Yes, it's low solute.
So we were first talking about what the concentration, now we're talking about the water?
Well, first time we're talking about the solute concentration. Now we're talking about the what? The solvent concentration, right? The concentration of solvent is 20% outside. The concentration of solvent is 80% inside. Solvent. Do you see why I told you how to know those definitions of solute, solvent, and solution, right? You will not understand what the heck is going on if you don't.
So the outside.
So now the water's going to move. In which direction will water move? From high to low. Where's it high? Where's water high? Inside. And so water's going to move out. Water will move out. So look at it. Look at what happens. If the solute can move in a hypertonic solution, in other words, the solute outside is higher in a hypertonic solution, then what's going to happen is the solute will move in, no problem. Water won't move at all, or at least not much. There'll be movement of water back and forth, but there won't be any net movement of water in any direction. Because the solute's moving, and you'll get equilibrium that way. If you can't move the solute, then what's going to happen is the solvent will move, the water will move. That water movement is called what? Who remembers from a minute ago? Osmosis. If you can't move the solute, then the water will move. So that's why we know the water's going to move outward in a hypertonic solution. Why? Because the solute can't move, and it's higher inside than it is outside. That's the definition of hypertonic, right? So let's go back. It's going to be confusing when you try to do these on your own. But look at what the summary slide says. It says what? In a hypertonic solution, what happens? And now you know why it moves out. And what happens to the cell? It shrinks. So when you put that egg overnight into a hypertonic solution, the next day, would you expect that cell to weigh less or weigh more?
Way less.
Way less, right? Does that make sense? If this is true, then this is a hypothesis, right? Did you notice that was a hypothesis?
Yeah.
If this is true, then when I put it in a hypertonic solution, I should be able to weigh a difference. It should weigh less. Right? Easy way to test if this is true or not. All right, so that was hypertonic, right? Now let's look at hypotonic. What do you think is going to happen in hypotonic?
It's gonna get bigger.
It's going to get bigger. Very good. Excellent. Don't even worry about all that beeping and nonsense.
Hypo.
Now we're going to do hypo. So here you have a cell. Now let's do hypo, which means what? Is it going to be high outside solute or inside?
Inside.
Inside's going to be high. That's good.
The salt.
So solute's going to be 80% inside, and the water is going to be what? 20% inside. Remember, we're doing 100% on the inside. Outside's, let's just do an easy one. Say 20. They're not always going to be this easy. Say 20, and let's say the outside is what then? 80% water, right? The key is that they're always going to tell you this number. You're going to have to try to figure out where it's high, or you're going to do two ways. Guys, you can do this two ways. Either you memorize what happens with water in a hypo, iso, and hypertonic solution, or you understand the foundational concepts and you apply them. My suggestion, if it's possible, if it's easy enough for you to understand it, to do the foundational concepts. Because at the same time, you will learn what to do when the solute moves across the membrane and what happens when the solute doesn't move across the membrane. By the way, this is all very important in what situation? What human situation is this important? Almost everything that happens in your body. When women, I say women or men, but women, I think of women because of a woman's period, right? As a woman has her monthly period, sometimes women swell. What's happening? Your tissues swell, they bloat, right? You've at least heard, if it doesn't happen to you, you know that happens to some women, right? That what's happening is water's moving. Water's filling the tissues. Why is the water moving? Because you're in a hypotonic, so you're out of balance, and once your the water starts to move to get back to equilibrium. When you take drugs, when you eat too much salt, for instance, if you're a person that loves to put salt on French fries and salt on everything, you're eating too much salt and you start to get older, what happens is, and for a lot of us, this happens to a lot of us, not me, thank God yet, I hope not ever, but what happens is that all that salt is salt in your blood. Salt doesn't cross the membrane easily, right? What's going to happen to where's the water going to flow? It's high in your blood. Where's the water going to flow? Out of the cells and into your blood. So your blood's going to get filled with a lot more water than normally would have. And what happens to your blood pressure? It goes up. That's because the water leaves your cells and goes into your blood. So high blood pressure is an application of this process.
So this is hypertension.
Hypertension is the result of water moving because of an imbalance in the solutes. Right? And it's just that simple. Of course, it's a lot more complicated factors, but it's just that simple. Now, dialysis. You've heard of people being in dialysis.
Yeah.
In dialysis, we use something called reverse osmosis to take the solutes and replace the water. So this process of osmosis and diffusion happens all the time everywhere in your body, and as a future physician, it's something that's important that you understand, or nurse, or healthcare professional, or human being that might have these issues, or children that have these issues, or husbands or wives that have these issues, right? So anyways.
We get it.
All right, I just wanted to make sure you understood how important this is. So osmosis is when you have 20% outside, 80% inside. In this case, it's what? What is this? What are we talking about? Of course, that's a solute. What are we dealing with? What is this? Hypo, iso? Hypo. That's right, because it's outside is lower, so it's hypo. So we know that's hypotonic. Look at how much we know just by memorizing it. And just because you answer it here doesn't mean you're going to remember it on the test. So you need to recite. You need to make those cards and keep flashing them over and over again, right?
I thought it was higher outside.
No, hypo means lower. Hyper means higher. So it's good. It's good. Hey guys, see what he's doing? What he's doing now is absolutely right. This is where you get it wrong now. Get it wrong now. Be brave so that get it right on the test. Yeah. Oh, no question, right? So it's hypotonic. Fine. Great. If the solute moves, what direction would the solute move? If the solute moved, it would. Everything's moving from high to low, guys. If the solute is moving, in what direction? It's going to move out, right? Because it's higher. Look at this: 80% here. It's only 20% outside, right? This is outside the cell, and here's inside. We're good.
So hyper was moving inside.
Right. We'll look back at that, and you can rewind it. When I post this, you can rewind and look at it. But yes, hyper would be higher outside, and so it would move into the cell. With hypo, we're talking solute here, right? We're talking about the solute. This is where you're going to get confused. Wait a minute, is this the solute that's moving, or is it the water that's moving? Which one's higher? Which one's lower? I'm confused. That you need to take this step by step. One little piece at a time. Are we clear? So the solute, if the solute can move, the solute's going to go from inside to outside in this situation. Does everybody see that? Inside to outside. Does anybody have a problem with that? Why inside to outside? Because it's higher here and it's lower here. We're good?
Yes, sir.
But now let's say that we're talking about osmosis, so let's say that this does not move. The solute cannot move. In what direction? The solvent's going to move. In what direction is the solvent going to move?
Outside to inside.
Outside to inside. Why? Because it's higher outside. Because it's higher outside than it is inside. Yes. It's 20% inside and it's 80% outside. So you're going to get the movement of water from outside to inside. Do you agree? All right. I hope you understand that this is lower, water's lower, and water's higher, outside, lower, inside. So water's going to move from high to low, from outside to inside. Now, that's the explanation of all the processes that are going on. If you understand that, I can't imagine, if you take your time and go carefully, I can't imagine you'd get a question wrong on that. I can't imagine. Yeah.
I'm kind of confused on how this works. So it would be hypotonic because of the water, right? Not the solute.
No. That's good. I'm glad you asked. You want to break it down into steps? Would it help to break it down into steps? Let's do that. So, step one, right? Step one. Let me change the color here. Step one is, where is the solute highest? That's the first question you ask, right? Where's the solute high, outside or inside? Question two, and you could ask one or two in whatever order you want, right? Question two is, does it move across the membrane? So that's the other question, because some things will move quickly across the membrane and some things won't, right? We're good? Question three, is it hyper, hypo, or iso? Right? How do you decide if it's hyper, hypo, or isotonic? It all depends on the concentration of what? The solute. That's what defines it. That's it. That's all there is to it. Are we clear?
Yeah.
Defining what, if it's hyper, hypo, or iso, all depends on the concentration of the solute. That's all there is. That's it. So if it's outside, concentration of solute outside, right? So if it's high concentration solute outside, what is it?
Wait, solid outside?
High concentration of solute outside, hyper. Solute, high concentration of solute inside, hypo. And same concentration, iso. That's it. That's it. We're done with that. Don't get, that's it. You're defining one of those three situations, and it all depends on where the concentration of solute is the highest. Yes.
For ISO, where, since it's equal, does it move from high to low, or does it stay?
Well, if it's equal, there's no high or low, right? There's, right? So there's no high or low, so nothing's moving. Well, there is moving. There's movement, but what? What do we? They're moving what? No net movement, because every one that goes in, one comes out, right? So it's no net movement. So it is movement, but it's just not any net movement, right? In ISO. Are we all good with that? So then, now the fourth step, you got a choice to make. So you got two possible answers, right? Depending on the answer to number 2, right? Number 2 is going to define which one you ask. Does the solute move? If so, where? Right? Does that make sense?
Yes.
And then, if it doesn't move, what do you have to ask? In which direction does the water move? In which direction does the water move? If the solute does not move, or this is only if, let me write that down, if solute does not move, right? If the solute does not move, then you have to ask the question, in which direction is the water going to move? If they're equal, if they're 50-50 on both sides of the membrane, is there going to be any net movement? Will water move? The water's always moving in both directions, so there's no net movement. Are we good with that?
Yes.
So what do we think? Did we understand this? Does that help you? Did that help you?
So these are the steps we ask ourselves.
These are the questions you ask yourselves. You're constantly asking yourself these questions. You see a problem? Let me tell you, once you get this, you see a problem about osmosis or diffusion on the end of course exam, the state exam, you're going to be like, yes, I got this. And you take it one question at a time, and you make sure you're checking your answers, right? 1, where's the solute the highest? 2, does the membrane, does it move across the membrane? 3, if it moves across, is it hyper, hypo, or iso? 4, if the solute doesn't move, or if the solute does move, in which direction does the solute move? And 5, if the solute doesn't move, in which direction does the water move? So those are the things you're answering. Question.
Can you give us a practice test question?
Oh, I'm going to give you a whole set of problems tomorrow during your first lab while you're setting up for dissolving the eggs. You're going to dissolve the egg shells. You're going to go ahead and start answering some questions in teams tomorrow. I have the whole activity designed. Yeah.
For number 4, where you say it's so weird, does that mean like from high to low and low to high?
Into or out of the cell? Left or right? So what direction is this stuff moving? Yeah. Yeah, tomorrow you'll need your lab equipment, yeah.
When is our next test?
Friday.
Friday, I told you that. All right. I did. So let's go on and let's finish this, right? It's 48, so I think we have time to finish it, and then maybe we can do some practice problems. All right? So let's see if we can remember how. So we're going to go ahead and we'll leave it there. Don't forget, there's two things you should always remember. Which way does water move when you're dealing with a hypertonic solution, and which way does water move hypotonic, and which way does water move net if it's isotonic. Now, you have to understand when water moves, there's a consequence to that. There's something that happens because water's moving. Either the cell is shrinking and there's a loss of mass, the cell is swelling and there's a what? Gain of mass, or the cell, there's no net change, so the volume stays the same. So those are your three possibilities. Are we all good with that?
Yes.
All right. So this is what happens. This is a nice little graphic that I think it summarizes what we just talked about. If the fluid outside the cell has lower free water molecules, lower water, right? How do you know if it has lower water? It all depends on that 100%, right? So let me go ahead and draw it. Let me draw this for you. Let me shrink this down a little bit and then draw it out. Here's number one. Let me draw a different color. So number one, if we were going to draw it, it would look something like lower what? Lower. If you have a cytoplasm, where's the cytoplasm? Inside the cell. Excellent. And where's the free? So if we have a lower water outside, so we can can I pick a number? If I want to understand, I'm going to go ahead and say, well, this is solvent. I'm going to say lower outside, right? I'm going to say 30. I'll pick a number, doesn't matter. If it's 30 outside, then what's the solute? 70 solute.
Oh, the lower.
And the water, they're talking about water. Lower free water. You see what they told you? Lower free water. So this is water. And this is all where? Outside. And of course the other one's cytoplasm. And in the cytoplasm we have what's the solute? If we said, well, let's do water because we know water. They told us water. It's outside's 30. What's going to be outside for? What do you want to do? You want to make it opposite just to make it easy on you? It's not always going to be that way, but let's say 70 here. Water. And what is it? Inside the cell for a solute? Let's say 30. All right. Are we good with that? All right.
When did we get our books?
Lord Jesus Christ, where did that even come from? So 30 solute, 30% solute, 70%, right? Inside. We all good? All right, so lower free oxygen or free water molecule concentration in cytoplasm, we call it what? Hypertonic. Everybody agree with that, right? Because look, 70%. Now, you can memorize that it's lower water concentration outside is hypertonic if you want, but that doesn't make sense to me. Hyper means high, and that means solute. Okay? And so it's hypertonic, and so what's going to happen to this water? It's going to move from what to what? Outside to inside, really. The water's going to move outside to inside. You're telling me water's going to move in this direction. Why would it move in that direction? Is the water concentration higher inside the...
The outside is going to go in the inside.
See, this is what I've been warning you. This is good. We're making mistakes now.
Is the water going?
What people are saying, I'll say again, listen carefully. People are looking at the 70%. And then they're looking at the 30%. Right? And they're saying, well, water's going to move from outside to inside because it's high here and low here, right? That's what people are saying.
Oh, you said water.
But I said water.
Oh.
Where is water higher?
Inside. So it's gonna move outside.
It's just gonna move out.
Oh.
It's gonna move out. So that's why I asked you to ask those 5 questions. You have to know what you're asking. It's a process. You have to follow a process. There's a logic behind it. You can't just jump at things. There's no quick answer. This is high school. The quick answers are done. So you have to take it one step at a time. First question, right, is what? Who wrote them down?
Where is the solute the highest?
Where's the solute the highest? Where is it?
Outside.
Outside. So what? So that's the next question.
Does it move across the membrane?
Does it move across the membrane? In this case, no.
When does it move across the membrane?
When it's small and non-polar.
Right.
So no, it doesn't cross. It doesn't cross the membrane, right?
And most of those questions will tell us if it's.
You follow these questions, you'll know the answer. Next question. Is this hyper, hypo, or iso? Hyper. It says it right here, hyper. Why is it hyper? Because it's higher outside than inside. When you're hyper, you're what? More active, right? Oh, he's hyper. He's more active. All right. So that's 70. So now, the next question is what?
Does the solute move? If so, where?
Is the solute moving? No, because it's not moving across the membrane. So which direction does water move? So which direction now is water moving? From inside to outside. High
To low.
high to low. This is high, and this is what? Low.
It's moving to where?
From high to low. So it's got to move outside.
I said it.
So let's double check here. If you're putting water, I don't care if you memorize these or if you work out the problem the way we just did. If you put a cell in a hypertonic solution, what's going to happen? It's going to shrink. If the solute cannot move, then the water's going to leave. It's going to shrink up. The cell shrinks, less mass, right? If you put a cell in a hypotonic solution, then water's going to go in. And I'm not going to go through all the steps I just did. I'd like you to go do that for homework as you watch this video if you can't remember or if you wrote it down in your notes. Finish these. Do what I did here for hypo and then again for iso. But this chart summarizes it. You can do it at home. I'll collect it for homework tomorrow. Are we clear?
You can make your own numbers, right?
Yeah, make your own numbers. Are we clear? Do you understand the assignment?
No. Wait, I got a question.
Let me say it clearly one more time, and then you can come after class and ask me. Your assignment for homework is what I just did for hypertonic. I need you to go home and do for hypotonic and for isotonic. What I just did here. Draw the same drawings, make up your own numbers, do them for hypo, draw your arrows, follow the 5 steps, answer the 5 questions. Question. Huh? You can. I'll post it tonight, but you're right. It could take a while to post it, so you might want to take a picture. I want you to do the same thing that you just took notes on for hypo, hyper that we just did for hyper. I want you to do it for hypo and iso.
Can you make it bigger?
Sure can.
So Mr. Mendoza, there are more, in some problems, the solute don't move.
Yes,
Some problems, some problems, the water don't move.
that's right. And then you're going to have to figure out when that is.
Depends on what the question asks.
That's exactly right. You got it. It all depends on the question. Isn't that a bummer? It's confusing, isn't it? If you're not, it's not horribly confusing, but if you jump around, you're going to get it wrong.
You want to make a.
If you take it one step at a time, you'll get it right. That's really what it comes down
You
to.
want us to make a whole nother chart like this, or you want us to make the cups, or we're gonna make.
What I want you to do is this. I want you to take this. What we did for hypertonic. You see here. What we did here for hypertonic. I want you to do for hypotonic and isotonic. Yeah. It's either small and nonpolar, in which case it'll move. They'll tell you oxygen gas. Is that going to move or not?
Yes.
Okay. They'll tell you glucose. Is that going to move or not? Well, you have to be told, right? Are there proteins in the membrane or not? We don't know. They have to tell you. So they will tell you in the problem. 99% of the time you're told in the problem whether,
That's what I was asking.
yeah, then that's the answer to your question. You're told in the problem whether some information is going to let you know if it crosses or not. All right, that's it for today. So, as I said, the white here is actually all amino acids, AA for amino acids, and it's called albumin, and you see here it says white. It's not actually white, it's clear, but when you cook it, it turns white, okay? So made of protein and water, it protects the yolk. It does protect the yolk, it's also the source of protein for the chick. The yolk is made of fat, proteins, cholesterol, water, vitamins, and minerals. Everything a young chick needs for growing. Everything you need to do, everything you need for growing a chick. Yeah. I wouldn't eat raw eggs because of the danger of salmonella. As I try to tell you, chicken eggs come out of chickens, and they come out of the same hole that chickens poop out of and pee out of. Birds have one orifice for things exiting their body. It's called a cloaca. And because of that, the outside chicken eggs can be contaminated with the bacteria known as salmonella. And salmonella can make you sick, if not kill you. All right? So don't eat raw eggs. Cook your eggs, cook your chicken. When you're done preparing, rinse out your various containers that had raw egg in it or raw chicken, and rinse it out with warm water and soap so that you minimize the chances of you getting salmonella poisoning. Okay? So no, I would not eat it raw. But are eggs good for you? Yes. Most people consider eggs a good source of protein. Some studies show that cholesterol from the diet has very little to do with high cholesterol in your blood, but it does have cholesterol. Eggs do have cholesterol, so you have to consider that. Other than that, there really isn't. Eggs are really a wonderful food, as far as I know. Yeah.
Is it true that, like, some people say that eating raw eggs is, like, good for you, but they say it's only good for you if you drink it really fast?
I don't know I don't know. I just, as I said, the problem with raw eggs is the danger of salmonella poisoning. The issue of, I would tell you that anything cooked is easier for you to digest. So if you cook it, it's going to be easier for you to digest. Eating raw eggs, I don't know why anyone would eat it raw. All the things in an egg are, my grandmother used to eat them raw. It's really weird. She put a little hole in the top of the egg and then suck it out. I don't know why. It was gross. All I can tell you is I don't know why she did it. People say that, I've heard it. I don't know of any reason why someone would want to eat a raw egg. It tastes better cooked, in my opinion. I've had a raw egg before. I don't think it's very good. It's slimy. It reminds me of oysters, but oysters have better texture. As far as all that goes, I would say that you're better off cooking it in whatever way you want. Now, you notice this thing here has this thing called a chalaza, right? Why do you think the chalaza is there? To suspend the yolk in the middle of the albumin to give it support, right? So when you look at the egg tomorrow, what are we getting rid of? The shell. And what we're doing is we're putting together calcium carbonate and calcium carbonate, CO3. And we're adding to it acetic acid, but let's just say we're adding to it acetic acid. I don't want to ACE, right? Acetic acid. And what we're going to get in the end, and this is not a balanced equation, what we're going to get at the end is CO2 gas, and that's why you see who did the lab, who made their observations? What did you see? Bubbles. What do you think those bubbles are? The shell? Look at this and tell me what you think the shell is.
It's saying what it is. It says calcium carbonate.
Right, okay, and what do you think the bubbles are?
And carbon.
Nope,
Oh,
It's ACE. And it's acetic acid.
nope.
Carbon,
carbon.
You guys, you gotta think.
osmosis.
Calcium carbonate, acetic acid, and makes CO2. What do you think the bubbles are?
Gas.
What gas?
CO2.
CO2. So to draw out the balanced chemical equation would be CaCO3 plus CH3COOH yields CaCH3. This is acetate, which is a salt of the acetic acid. And there's two of these, and plus water plus CO2. Now that looks complicated, so I didn't want to write it, but this is the chemical equation. So what we're saying with this chemical equation is calcium carbonate, which is what? The shell, is going to mix with acetic acid. That's what this is what vinegar looks like, right? The active ingredient of vinegar is CH3COOH. And this hydrogen is going to leave and go into this solution. That's what makes it an acid. And together, it's going to form water and CO2. One of the oxygens from the CO3 is going to go with the hydrogen and make water, and the other two are going to go off in the form of CO2, and the calcium is going to go and bind to this part, right? To this part of the acetic acid. So the calcium is going to come over here and make this, right? And then one of the oxygens is going to go with the hydrogen, two hydrogens, and make water, right? And then what you'll get is you get CO2 being formed as a bubble. So when you look inside that beaker, what you see is a bunch of bubbles on the outside of the shell. Do you think you need to know this equation?
Yeah.
No.
No.
No, you don't need to know it. I just drew it out for you just to explain it.
So what's
Will you eventually have to know the chemistry, a chemical balance, chemical equation, know how things move around? Absolutely, but not in this class.
So the egg plus, so basically, which one is the egg?
The whole thing's the egg.
I'm talking about like.
The cell. You mean, where's the cell, right? And so the cell, this air cell is not really a cell. It's just, they call it a cell because it has like a little pocket. I hate when they call it a cell. On the yolk, they don't show it here, but on the yolk, there's a tiny little structure that's this cell. So the actual cell is sitting here. But there's a lot of membranes in the egg. The outer shell is going to dissolve, and what you're going to get right here is a membrane. And that membrane is selectively permeable. Isn't that useful for us?
Yeah, that's like an ocean.
That's right. It's exactly the type of membrane that surrounds the cell. So the plasma membrane around the cell is over here, but here there's a whole structure, there's a whole membrane that's put around this whole thing that protects it, that lets some things in and some things not. And this is a perfect membrane for us to use for experiments, right? So that's what we're going to use. Question?
So you know how you boil the egg and you go to peel it, right? Skin that be on there? Can you
All right.
crack the egg and peel it off and that little skin be on there?
Yeah. This membrane would be the skin, yeah. And then the albumin's right underneath. That's a good point.
Is that
When you boil an egg and you remove the shell, there's a little thin, it's hard, it's made hard by cooking. Once you cook it, you've changed it. It's not permeable anymore. You made it impermeable. So it's not very tasty. Most people just throw it away, right? It's that thin layer that's on the outside of the white, right? That is, in fact, the membrane. So good call on that. I was actually going to say. The air cell is just something they call it an air cell, and really all it is just a pocket of air. So don't think of it as a cell. I don't like. Unfortunately, the only people that make these egg anatomy chicken eggs are people that sell chicken eggs. So I'm sure that there's a good source of what an egg really looks like in all the biological terms, but air cell is not. I don't think it's a good name for it because it's not an actual cell. Yeah.
So, okay, how do you pronounce the chalaza?
Chalaza. Yeah, go
Chalaza?
ahead.
Okay, so when you crack an egg and it's like that mucusy, like yellow type clump in it, is that?
It could be. It's not really going to be yellow.
I
Now,
mean, it's never
have you ever opened an egg? This happens very rarely now, but when I was a kid, it happened once in a while. There'd be a little red spot, almost like blood sitting right here.
No.
Well, it happens still especially if you get organic chickens or chickens that are grown in like somebody's backyard. That'll happen sometimes, and what that is that's the egg. That's the egg that was developing. So that was a fertilized egg. That was the embryo.
So you can eat and you ate.
You can get blood in an egg, yeah, because chickens, an egg was a living thing, right? And if it gets fertilized, it'll start to become a chick. And if you crack it open before it becomes a chick, you will see little bits of blood, a little dot of blood. That dot of blood was the embryo. It's just you stopped it from growing, right?
That inner outer shell.
Right, so let's move on. Let's talk a little bit about the effects of osmosis. Then I want to talking there about. Let's talk about the effects of osmosis. Then we'll go through some practice problems. You'll identify. You'll be able to answer them, I'm sure, and you'll let me know. It'll be interesting when we do it. All right, plants and fungi have cell walls to help regulate. Right? We all know that.
No.
Who said no? Who said that they didn't know plants have cell walls? All right, so fungi and plants have cell walls, but you know what other things have cell walls? Bacteria have cell walls too, and fungi and plants and some protists, right? So we know that it's not just these, but help regulate. And most plants are the healthiest in the hypotonic environment. And let's talk about what hypotonic is. And they do say most plants. You can tell me what plant do you think would not be healthy in a hypotonic environment. So what does hypotonic environment mean? Do you have more water or more solute?
More solute.
Hypotonic, more solute. Who
Yes.
studied and who didn't study? It'd be more water.
It'd be more water because it's coming out.
Hypo means lower, so lower solute in the solution. So we'd expect that this plant, whatever it is growing where there's land, there's soil, obviously if it's a terrestrial plant. There's plenty of water,
So the
right?
plant can grow there.
Huh? There's plenty of water. A lot of water, more water. So it's hypotonic because it has more water. Most plants like a lot of water. You agree?
Yes.
If you don't water plants, what happens to them?
They die.
They
But
die.
you drown them
Such thing as
too.
overwatering.
There are such things as overwatering. We don't want to be too much. You'll see what happens when you overwater plants tomorrow. Actually, the next day, once you look at your cell that has been in hypotonic solution. If it's in hypotonic solutions too long, then the cells do end up rupturing. But why is it? We know what happens in a hypotonic solution. We know that if we took a cell, a plant or animal, any cell, and you put it in a hypotonic solution,
So would a hypotonic environment be like the rainforest?
anytime it rains a lot, it would be hypotonic. When it doesn't rain a lot, it would not be hypotonic, because the more rain you have, the more water you have.
So the desert is not.
The desert would be not a
So
hypotonic.
would it be a hyper?
Yeah, probably. Any water source would probably be hypertonic. So hypotonic here, what we're talking about, what would happen in this case, in this hypotonic solution, what would happen? Anybody that studied? Did anybody study? What would happen to this cell in a hypotonic solution?
It will
It'll swell.
It'll swell. It'll swell, because water's gonna rush in. And so you have to memorize that. Either memorize it or figure it out. As soon as you see that, if somebody tells you that the solution is hypotonic, you're done. You know it's gonna swell up. If you don't know swell up, then you think hypotonic, which means the outside is lower in solute concentration, the solute doesn't move, so the water's going to move in the opposite direction of the solute, would move if it could, and blah, 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 blah.
And you said the example was like being pregnant. period?
Well, the period and the pregnant are ways, examples of how osmosis impacts living creatures, right? And in the case of placental mammals, mammals that have placenta, like humans, we have our females go through menstrual cycles, right? And that's true for dogs and cats and humans and everything that has a placenta, right? So the idea is that this movement of water back and forth across the membrane is indeed the cause of a lot of the biological changes that happen to the female during her pregnancy or during menstruation. So in any case, hypotonic means that water is going to rush into the cell. Do we agree?
Yes.
Okay. So why does this tree, how can this tree be in a hypotonic solution? Why doesn't this plant blow up? Because eventually what's going to happen? It's going to swell until what? Till it bursts. It'll literally burst. Okay? So what's going to stop it from bursting like that? The cell wall. So that's why the cell wall helps regulate. The cell wall helps regulate because the cell wall is for both fungi and plants, and again with protists, and that's why things that can't move around very much need to have some kind of structure to help them. If they can't move from one place to another, they have to have a way to stop themselves from when the environment changes. If it changes hypotonic, for instance, a lot of rain one day, like the hurricane that hit in the south, right? That probably killed a lot of trees, not just because of the winds knocking them down and uprooting them, but because of the extreme hypotonic solution that the rain caused. And you might say drowned, but it's not really drowning because they don't really breathe like us. Their root systems don't take in the carbon dioxide or oxygen. They actually make their own oxygen. So it's not really drowning. What it is the cells literally burst. So what most people like to say is that plants, you can drown a plant, but it's really not drowning them, right? So some unicellular eukaryotes have contractile vacuoles that force water in and out of the cell. We know that, right? We remember that from our cell studies. Is that right?
Yeah.
All right, so you have a central contractile vacuole. We've looked at them. You have them in your cell projects if you have that in your binder the way you should. You have animal cells do not have cell walls or contractile vacuoles. They actively remove solutes from the cytoplasm. So what animals do, we don't use a contractile vacuole. We don't have a cell wall. We move the solutes around. But that gets us into trouble if we can't move the solutes around, like something like sugar. When you're diabetic and you can't get the sugar out of your blood, then your blood starts to become hypertonic, which means what happens to your blood pressure? It goes up. So there's a lot of issues with our strategy for survival. So now let's take a look. Here's some sample problems. Let's do a YouTube problem, and I'm not talking about the video YouTube. I'm talking about a tube that's a U-shape, right? So if you have water that's filled up in a U-shaped tube, you realize that this is what's going to happen, right? And yet this is the water level. Let's call it the solution level, because it's a solution. And so that's the beginnings level solution, right? The beginning, before. Then you have a little kind of this membrane here. All right, you add some solute on both sides, and the solute you add is sodium. It's not permeable. So let me write this down. Not permeable. What does permeable mean? It can't. In this case, because it says not, it's not. Doesn't allow things through. Doesn't allow things through. Yeah, I'll show you in a second. But yes, it's sodium. To sodium ion. Now you see how every problem is different, right? This was not permeable to sodium plus. These problems it is, right? So you got to be careful. All right, so let's say that on this side you have 10% sodium ion. And on this side you have 20% sodium ion. So ask your 5 questions. Ask your 5 questions, and let's do it. Let's ask our 5 questions, and let's see what happens. Somebody ask the 5 questions. Where's the solute the highest? The right side is the highest, right? So the question is, what's going to happen? The question is, how is this going to change? Where is the sodium the highest? Sodium is highest, and I should have wrote that down, Na plus. Sodium is highest on the right side, right? So number 1 on right. Solute or sodium, highest, right? Up arrow for highest. We all good with that? Concentration, Na plus. The time is irrelevant. Pay attention. 2, what's the second thing? Does it cross the membrane? No, it does not. No, it does not cross the membrane. 3. Is the right side hypo? Now here's the problem. This isn't a cell, right? With these homework problems, you can answer and ask that question. Is the right side hyper or hypotonic to the left side? Hyper. Why is it hyper? Because it's a higher concentration. So the right side is hypertonic to the left side. Do you agree? Okay. 4. There's a solute moving. Is it? How did you answer number 2? So no, it's not moving. So what's going to move because the solute doesn't move? Water. So which way is water going to move?
To the left. Oh wait, we got to see how much percent.
You can do it that way. You can do it that way. That's right. So here's your question. With 20%, if you have 20% sodium, what percent water do you have?
80.
So you have 80% water. And this side is 10% sodium. So what is it? 90%. Which side? So which side's higher water? Left. So it's high to low. So which direction is it going to go? It's going to go to the right. So what does that mean? The kind of problem they'll give you on an end of course exam is you have to see all this work we just did, everything here on this side that we just did, is just to answer this question. The only question they'll ask you is, what does the water look like after? That's it. And here's what the answer would be. And it would be like 15%, and that's a guess on the percentage. And because the water's moving, this side would go up and this side would come down, right? 15% what? You tell me.
Well, I thought
The solute was 10% and was 20%, but as the water leaves this left side and goes to the right, the left side becomes more concentrated and the right side becomes less concentrated until you get equilibrium. Is when both sides are equal. So now they're isotonic. So every time a water molecule goes one way, a water molecule goes the other, it's equilibrium. So that's kind of tough. That was a tough one, right? So
he did.
the direction was to the right in number, and so this would be right. And because of the answers to these 5 questions, what would happen is that water on the right side would go up, and the water on the left side would go down. And because sodium doesn't pass, as you get less water, sodium becomes a bigger percentage of the solution. And because you have more water now on the right side, sodium becomes less concentrated on the right. And that's your answers. Please try to do this. Remember, don't get too frustrated. We'll go over it. Please write down your questions. It'll improve your grade on your notebook. I will have, oh, by the way, blue sheets. We're turning blue sheets into at once every 2 weeks, and I'll make copies tomorrow, okay? Please put them over there so everybody
I
can
got a
grab them.
question. I got a question. So for number 4, what do you mean do it pass through the membrane?
All right, so number 2, we asked the question. Number 2, we asked, does the solute pass through the membrane? And we answered no, it doesn't, right? Then number 4, we said, does the solute move? Well, in this case, it doesn't. Why? Because it doesn't pass through.
So how you can tell by the picture that it don't pass through the membrane?
Say what?
How can you tell by the picture it don't pass through the membrane?
You don't. Somebody has to tell you. Did I tell you?
Oh, because it's not.
Because it's not permeable. Because I said it doesn't. If it says it's not permeable, it means it doesn't.
If it's permeable, then it does.
That's right. Permeable means it does, and not permeable means it doesn't.
So if it's not permeable, is it impermeable?
That's a good point. Impermeable is another way of saying not permeable.
Okay.
Right?
Yeah. So you staying or no?
I can stay and help anybody, but I don't want to help you with the homework problems. I want you to try to do those on your own.
I just need the Chromebook because I ain't had no Wi-Fi at the house. I just need to catch up on my notes. That's it. Or
Okay. You need to watch the videos.
yeah.
The videos are going to be 3 hours long. So can you go to the library?
Yeah, I can.
I would go to the library, put in your earphones, and at least stay an hour a night and watch the most recent one. I'm going to upload this video tonight,
Okay.
so you might want to try to do that tomorrow.
Okay.
But we're going to go through the problems. It's important you watch it so you understand how to do the problems, but you can give it a shot on your own and see what happens. Because remember, we're just going to go over them tomorrow.
Right.
I'm just going to check and see if you've done your homework tomorrow.
You say you print out blue sheets, right?
I'm going to print them out tomorrow. Questions? Let me read. We're still recording. Yes, we did, and I'll be posting it. Yeah, I am. Because I want any questions you have, I want to make sure I send them out. I'm going to post them tonight. But yeah, I have Mondays posted and Thursday, Fridays posted as well. Next. Questions? Try to do it tonight. I don't want to help you do it, so I'd rather you go and do it. If you're here and you're having trouble, I'm gonna feel like I should help you. Is that okay?
You know you want us to do it as like a quiz? So do
I
you,
want you to set it up as if it were an exam for yourself. Because you can almost think it's not a practice exam. I'm going to give you a practice exam. But when you do that, when you do work as if it's it's a test, then you're getting your mind ready for testing conditions. Does that make sense?
yeah, so even if we don't finish it after 40 minutes, you still want us to finish it, right?
Wait, say that again?
So even if we don't finish it after the time's finished, you still want us to finish it, right?
All right, you're going to have to say that again because I got interrupted. Go ahead.
Even if we don't finish it after the time is over, you still want us to finish it?
Yeah. Time yourself. If you feel like it's taking you too long, ask appropriate questions tomorrow when we're going over it. But yeah, I want you to try to do all the problems. And when you're having trouble with the problems, you guys can stay here till my wife comes to pick them up. You guys can stay here for a while. I'll be here, but I'd rather not help you because I'm trying not to. I want you to have the experience of going through this on your own. Does that make sense?
Yeah.
Or we can stay here to do it because like my brother doesn't come for another little bit longer.
Say that again.
Or we can stay here for a little bit because my brother has work and he's coming for.
Let me turn this off.